Hello, everyone. Welcome to Azure Community Conference. And thank you so much for joining my session, What You Need to Know About Security for Cloud DevOps. But first, let me give you a quick introduction about myself. My name is Mohamed Radwan. I'm a developer technologies MVP and principal DevOps consultant, worked on several projects for different enterprise customers across different regions and countries. I started back in 2002 as a classic ASP developer, relocated multiple times in multiple countries, worked with several technologies and for different roles and positions. And for the last 8 years, I moved to consultancy-based role where I focused more on helping different companies, some of them from the Fortune 500, to improve their software development and delivery using DevOps and automation. I have developed and authored several frameworks, command line tools, and guides. You can find them on GitHub and Azure DevOps Marketplace. I have presented many sessions in several user group conferences, events, and customer site as well in different countries. So I got the chance and the opportunity to work in different culture, project size, and company size as well, which helped me to have different experience. I like to share my experience. This is why I have a YouTube channel and blog where they have hundreds of videos and posts that share different topics from my real experience. Let's see the agenda of the session today. We are going to see a comparison between traditional security vs DevSecOps or RUG DevOps, so we can see how the security model evolved to keep up with continuous delivery. Then we will start to look at how to treat security as a continuously varying state. Then we will see how the evolving of the DevOps and how the software development industry has a new paradigm shift. After that, we will talk about the relation between continuous practices and shift left, so we can understand how shift left can affecting the continuous practices. Then we will talk about security and compliance within DevOps. Then after that, we will understand what do we need to check for security. So this will answer the question, what? Then we will have an introduction about vulnerabilities overview. Then we will answer the question how to check for security. After we understand what is the vulnerabilities, and then we will understand how we can achieve that. Then after that, we will take an overview about WASP or Open Web Application Security Projects and understand what is the product they produced and get more information about them. Then we will talk about an overview about Secure DevOps Kit, which is an internal tool developed by Microsoft and they shared with their customers. After that, we will talk about different types of scan using Security DevOps Kit. Then we will see the first demo, which is Security Verification Test Ad Hoc Scan. So in this video, we will cover how we can run the ad hoc scan. Then we will see the second demo, which is how to set up a continuous assurance on Azure subscription, which will create an Azure automation runbook, which will continuously run a scan on your Azure subscription. Then we will talk an overview about Azure Policy, and then we will talk about how to integrate Azure Policy with release management in Azure Pipeline, then how to automate governance and compliance within the DevOps. Then after that, we will talk about how to continuously securing validating CI/CD pipeline, which means that moving the conversation from the security instead of approving each release to approve the CI/CD. After that, we will see the third demo, which is check security in CI/CD pipelines. And this will be how we can integrate the security activity as a part of the continuous integration and continuous deployment pipeline. Then we will talk about the difference between passive penetration testing vs active penetration testing as a part of the CI/CD pipeline. Then we will talk about how to validate the infrastructure. And once we found vulnerability in any part of the CI/CD pipeline, how to track them so we don't forget them as a part of the software development lifecycle. And then the fourth and the last demo, which is how can we check for vulnerabilities and license compliance as a part of the CI/CD pipelines. As we moved from traditional development to Agile and DevOps, which means increasing the frequency of deployment in production. But this business agility should not come with the price and the expense of security. But the question here, can the current security model and practices keep up? The answer is no, because the current security practices is not flexible enough to keep with that change. So it is important to stop treating security as a milestone and instead treating security as a continuous varying state. So with this in mind and continuous delivery, how do you ensure that your applications are secure and stay secure? How can you find and fix security issues early in the process? All of that practices commonly referred as DevSecOps. So DevSecOps incorporates the security team and their capabilities into the DevOps practices, making security responsibility of everyone on the team. In DevOps, we have many continuous practices like continuous integration, continuous deployment, continuous delivery, and continuous testing. And as we are going to treat security as a continuous varying state, we should also implement continuous assurance as a part of our DevOps practices. I think one of the very important paradigm shift in our software industry, the concept of shift left and shift right. So shift left, it's all about moving the practices that we usually doing them at the late stages in the process to be at the very early in the beginning. Like for example, testing. So we moving testing to be with the development, which will help to produce faster software with high quality. But building quality from the beginning is not enough. We need also to shift right, which means getting the data from production. So the ability to monitor application and getting real-time data from production is very important. So some practices like AMP testing, testing in production, canary testing, it's very important as well as shift right practices. There is a relationship between continuous practices and shift left. So if we look at software development stages or life cycle, and when we usually having the security practices, we can see that usually it's before deployment. But within DevOps, we need to shift left security practices at the very early at the beginning, which mean that with the development. But it doesn't mean that this is only the practices at the beginning. It means that I will continuously doing that practices along with the process. And this is why I'm going to treat security as a continuous practices or continuous varying state. Talking about DevOps, we are not in the position that we try to defend that DevOps is not bad for security. We went even further and see that DevOps is better for security. Because by moving fast, we become more secure because we are not standing in vulnerable position for a long time. It's very simple. Because compliance relies on automation, which means that we are going to automate the compliance by automate the pipeline and certify the pipeline instead of certify each release, which means switching the conversation with the security team to approve the pipeline with the ability to monitor and audit all the process at any point of time. So security needs to shift from the end to be evaluated at every step of the process. Securing application is a continuously process. So let's look at the security development lifecycle. When we look at the entire software development lifecycle, the security practices, as we explained before, it is a continuously varying state, which means that I have a security practices in each stage. So for example, when I'm talking about planning, we have the security requirements. So I should capture the security requirement, which is non-functional requirement. I should also include that as a part of the security acceptance criteria. So either for the non-functional or even for the functional, you should have a security acceptance criteria from the security perspective. When we look for the code, we need to check for the source code vulnerability or for the open source software license vulnerabilities or allowance. Also look at the open source outdated. And in order to do that, we will use the static application security testing as a part of our practices. Also, for the infrastructure, I should security scan the infrastructure as code to prevent creating insecure environment. Or I can scan the actual environment so I can understand the drift status between the baseline and the current state. And in order to do that, we're using Secure DevOps Kit. And again, this is some of the examples of the tools and technologies, but there is many. When I look on other stages, we need also to embrace common vulnerability and the exposures information. So for example, running some passive penetration testing, which is a dynamic analysis, or active penetration testing, which is a dynamic analysis as well, but this will take more and long time. We will see and get more information about all these practices in the coming slides and demos. And this will be using WASP product, which is a ZAB, which is a penetration testing tools. And in the monitor, we can use release gate, Azure policies, Azure blueprints, Azure Security Center. So what I'm trying to tell you here that in the software development lifecycle, we have several practices in each stage that we're using several technologies and tools to embrace these practices as a part of the DevOps practices. So let's answer the question, what? So what do we need to check in order to make sure that our application, infrastructure, environment is secure? First, we need to make sure that our source code is not having any vulnerabilities. And this is the source code that we wrote every day. Also, we need to check our open source software libraries vulnerabilities, because maybe we have a secure source code, but our libraries is not secure. We need also to check for the license allowance for the open source libraries, because, for example, the license may be not allowed to ship with a commercial application. So we need to make sure that the license allow. So we need to check for license allowance. We also need to check for the version of the library, because, for example, there is some libraries outdated, which mean that it is not maintained anymore. It will be risk to using that, not from the vulnerabilities, but from the risk of using an outdated, there is no response for fixing the problem or the issue, which mean that this will having an effect on my project. We also need to make sure that our infrastructure as code is secure, which means that this code are going to produce secure environment. So when I create environment based on this code, it will be secure. And this will usually we using for preventing creating insecure environment. We also need to check for actual environment, which mean that to measure or to understand the drift status. Because, for example, now we check our infrastructure as code, we create the environment, but for any reason, this environment to change, and we need to measure the drift status between the baseline and the current status of the environment. We also need to check for the common vulnerability and the exposures. So let's get overview about vulnerabilities. So for example, if we get some of the risk of having OSS libraries or open source vulnerabilities, if we look at data breach report from Verizon, we can see that 85% of the vulnerabilities in the last year is the same as the top 10 vulnerabilities for the previous years, which means that the hacker is still targeting the top 10 vulnerabilities. And this is due to the lack of awareness and practices. A common vulnerabilities and exposure database. It's a platform aimed to collect, maintain information about discovered computer security vulnerabilities. So for example, it will describe for the identified vulnerabilities, then potential impact on affected system, also any workaround or update to mitigate the issues. This common vulnerability and exposure database as a community effort. The National Vulnerabilities Database, which is another platform that depends on the Common Vulnerabilities Database. But this National Vulnerabilities Database is maintained or managed by the US government, and it provides an enhanced information for the Common Vulnerabilities Database. For example, it gives impact score and rate, severity scores as well. Also, it gives a security checklist, misconfiguration, and advanced search. So how do we check for security? The first is static application security testing. So static analysis, which mean that we're scanning the code without the need to run the application. And this is either our source code or library. We also infrastructure analysis, which mean that we're scanning the infrastructure as code to prevent or scanning the actual environment to understand the drift status from the baseline. And this is also by scanning. Passive penetration test, and this is dynamic analysis. And the dynamic analysis mean that I need to run the application in order to find the vulnerabilities. And the passive penetration test is targeting the site without trying to manipulate the data in order to find and expose more vulnerabilities. This is why passive penetration tests run fast, and this is the best candidate for continuous integration, which run in few minutes. The active penetration test, it's a dynamic analysis as well. And for the active penetration test, this is simulates the actual hacker commonly used techniques in order to try to find what the application or what is the website will reveal. This is why it tries huge number of different combination with data. This is why this scan taking very long time, and the best candidate pipeline to run this test is a part of the nightly build pipeline. Now we understand what and how. Let's understand more about tools and technologies for implementing security. So WASP, or Open Web Application Securing Project. So WASP is a worldwide non-profit organization dedicated to helping improving the quality of software. And they are producing two products. The first is the top 10 vulnerabilities document, and I just select some of them like injection, never trust any user, and many. And also they produce a ZAP, which is a software for penetration testing. And part of this ZAP is a weekly Docker image that has all the updates of the vulnerability. One of the most effective steps that organization could take toward strong, more secure software development culture would be to adopt the OWASP Top 10 as a part of the development guidance principle. Secure DevOps Kit for Azure. It is developed internally inside Microsoft and they share it with their customers. So it is an open source on GitHub, and it is group of PowerShell commandlet, extension, plugins, guidelines, and security best practices. It can provide to secure the subscription for policies, role-based access control, configuration, etc. It also can provide a security intelligence for coding, as well as ad hoc security verification test. It also has an extension for Azure Pipeline to support security scanning for infrastructure as a part of the pipeline, and also provide a continuous assurance runbook security scan, which will create an Azure automation with runbook that can run in a schedule to scan the Azure subscription. It also provides an analytics and alerting with monitoring for monitoring and alerting vulnerabilities, as well as risk governance. So it can run against your environment that cover over 30 Azure services today. It has more than 290 security control, and it gives a report with a fix script. Microsoft run this tool internally with Azure Automation to scan their Azure subscription once a day as a part of their continuous assurance inside Microsoft. So for example, when we look at the security intelligence, we can see that we need to install the extension as a Visual Studio extension. Once we install that extension, then this will prompt it for security intelligence as a part of the code. Also for the security verification test ad hoc, which will be run from the command line. We also run the continuous assurance verification test, which will install the continuous assurance verification test on Azure subscription that will create Azure automation and runbook. We can also run as a part of the build and deployment by having the extension for Azure Pipeline, which run to scan the infrastructure. So how we can run different types of security scan? To run the ad hoc, first we need to install the Azure DevOps Security Kit. Once we install it, we can see all the library or different commands. To run the ad hoc scan, we just need to run git Azure Services security status and give the subscription and the resource group if needed, or all the subscription. Once we run that, this will scan the subscription. This will generate a CSV result with all the control, the scan, with the status, and also a description. We will see that in the demo in details. I can also generate an autofix script, so I can run this PowerShell script to fix the problem. So let's see the first demo, which is running security verification test ad hoc scan. Using Azure DevOps Kit, we will use the ad hoc scan, continuous assurance, and build automation with CI/CD pipeline. So the first with ad hoc scan, I have a resource group I created just with standard template for Windows 10 virtual machine. And then with creating the machine, it's just creating a storage account and virtual network. So this is a standard template for Windows 10 machine. Then I have here my local machine. It's a remote machine that I will use to run my command. This also a clean Windows 10 machine. I didn't install anything. I just a fresh machine. So I will run a PowerShell in elevated mode. So let's make the screen much better so we can see all the command. So here I will set the execution policy to be unrestricted because I need that to import the library. Just agree about that. Confirm. Then I just run SP version table to make sure that, because I need at least version 5.1, so I can install the DevOps Kit library. And then here I will install the module, which is AzConfDev2020, and the scope will be the current user. In some cases, I may need to allow clopper. The allow clopper here will using to override any existing commandlet or library. For example, because this is a fresh machine, so I don't need it. But for example, maybe in your case, like you have already existing PowerShell modules on your machine, and you may need to override them. So just to run and install the DevOps Kit, I just need NuGet package provider. So now it install. Then confirm using the repository. Now the library is downloaded and installed. Then I just need to import the library. So import module AzConfDev2020. So this is just like the same as when we using a reference for the DLL, so I can use the command inside this library. So now the library is imported. Then let's first log into Azure, my Azure subscription. So using login Azure account, this will prompt it for my account. Just enter my credentials. Now I log in, and then I will run this command, which is git AzConfDev Azure Service Security Status. And then I give here the subscription if I want to scan all the subscription, give the resource group if I want to scan only particular resource group. And in our case, this is our resource group that has the virtual machine that targeted to scan. And also I give the switch of generating fixed script so I can fix the problem with the automated script. So let's run that. So I need to agree on the license. Now it starts scan 3 resources, the first section, now the second and the third. Once it completes the scanning, then it will open the folder with all the logging information. But let's see the output on the screen. So we can see that we have 28 controls scanned, and we can see that the severity here, for example, I can see what failed. For example, I have 5 failed with medium severity. So let's navigate to the folder where it has the scan result. So as we can see here, I have different files. So here, this is the 3 files for a file for each resource. So if I open, this is for the storage account, the logging for the storage account. Because this machine doesn't include Excel, so let me copy the CSV file to my local machine and double click the file. So here we can see this is the control scanned, and we have different columns. So as we can see here, the first column is the scanned controls, and we can see in the second column we have here the scan result. We have 4 result types. The first is verify, which means that it requires a human judge to take decision. And the second is a manual, which means that either the account running the scan is not have the permission enough to scan this control, or it is not supported to be automated. The second is failed, which means that this control failed, and we will have the recommended fix and description. The fourth result is passed, which means that you don't need to take any action. We also have here the severity of this, and here if it is baseline or not. And this column to indicate if this control support autofix or not. For example, virtual machine should have least OS version installed, so this will not be autofix like installing the update. This will not be as an autofix as a part of the DevOps kit. So for example, if we take this example like this, the storage audit request. So this failed because I need to enable the audit for login to the storage account, and by default when I create the virtual machine this was not enabled. So, and we can see here the description for that. This is 23rd, the problem, and also we can see the recommendation for how to fix that. And we can see that the recommendation including instructions and command. So I can using that to fix the problem. Let's navigate. Let's see the settings that is not enabled. So if I go for the storage account and navigate to diagnostics, we can see here the logging is not enabled, as we can see. So let's navigate to the autofix script. So I will open and just edit the script in PowerShell editor. Just loading. Once it's loaded, I can run the script. Of course, it has the JSON file which has all the parameters. And we can see that it will import the DevOps modules and fix the script. I didn't click anything, just auto fix with confirmation. This is the logging information. Let's get back to our Azure subscription and refresh here. So we can see that this enables the logging and fix the problem. Let's scanning the same subscription to see the difference. but I don't need to generate fix script this time. So this will do the same scanning. And I will copy the scan CSV file, the result CSV file. Let's open that. So here, this is the one that failed. Let's see how this will be in the second file. So here we can see that it's paused now. And it generates the same data. For example, it including all the fix and the same description. Now, let's see the second demo, which is how to set up and run continuous assurance scan for Azure subscription. So let's remove that again and save that for the storage. And now I will install the log analytics, create a resource because it's required for continuous assurance. Just to create log analytics. Name that. Resource group and choose a location. This will create the analytics. Just to navigate to my resource group and open the analytics. And here I will just need to copy the workspace ID because I will need it to install the continuous assurance scan. I also need to navigate to advanced settings so I can get the shared key. Once I get that, I will use the command line with PowerShell to install the continuous assurance. So as we can see, it is the same. I give the install continuous assurance, give the subscription, then choosing the resource group because I want to install continuous assurance for particular resource group. Then here the workspace ID, the log analytics workspace ID, and here the shared key. Of course, I can also provide an Azure automation, and if I didn't provide, this will be created as a part of installing the continuous assurance. So first, let's navigate to the resource group to see that we don't have any Azure automation account, and let's run the command. So this will run the command. It will take some time. And this will create service principals to be used to create other account and running and create the continuous assurance runbook and automation account. Now it's complete. Let's navigate to the Azure portal and see our resource group. Now we can see that now I have Azure account automation with name Azure Continuous Assurance. Let's navigate to this Azure account automation. We can see that it has even some tags like continuous assurance and with a version of the DevOps kit and so on. Let's navigate to the runbooks to see. We can see that there is a runbook created called the Continuous Assurance Runbook and it's published. And if we navigate to the jobs, we can see that it didn't run yet. And if I go for the schedule, we can see that we have created a schedule as a part of the continuous assurance installed. And it's configured after 10 minutes of the creation of the continuous assurance because it took like 8 minutes to create or to install the continuous assurance. I can, of course, change the schedule time if I need For example, I change that to be 9 o'clock. Let's close that. And now here I will just go for the log analytics, and of course I can query the log analytics to get more information about running the jobs. Here now I waited to run the continuous assurance runbook so we can see the runbook's log, input and output. So let's open the job, and we can see that here I can open the output and see the scanning of running that. So this is a continuous assurance scanning. And of course, I can uninstall or modify the installed continuous assurance. Security in CI/CD pipelines. For the build and deployment scan, I just need to install the extension on Azure Pipeline, and then I can check for security. For example, now I have my code, and then moving from the code to development, that's fine. But before moving the testing environment, then I will using the Azure Pipeline to scan the testing environment first to make sure that the testing environment is secured. Once it's secured, I will deploy my application to the test environment. Then I will use also the extension pipeline to scan the production environment. And again, if it is secure, then I will move my application. And of course, if the security failed, it means that I will not deploy my application to the next environment. And this, of course, will fail the build. Let's see the third demo, which is check security in CI/CD pipelines for infrastructure as code or actual environment using the Azure DevOps Kit extension. Now this is the third part, which is running the scan as a part of the pipeline CI/CD. So first I will go to the pipeline, create a new pipeline. I will use the classic. And here I will choose an empty pipeline. I will leave it. And here I will add AzConfDev2020. Searching for that, so it's not installed, so I will get it for free. Install the extension on my organization. Now it is installed. Then refresh so I can add. So search for AzConfDev2020. Now we can see that this is the two types of tasks. The first is to scan the ARM template or the infrastructure as code, and the second to scan the actual environment, which is in our case, we will use this one to scan the resource group. And here I will authenticate to my Azure subscription. I just need to authorize that. Prompt for my account, just to authorize. Then here I will choose that I want to give the resource group name, and here I will put my resource group name and my subscription ID. Then queue the build. So this will queue the build. So getting the agent. This repo just has a README file, so it doesn't include anything. Check out the files. And as we can see, it will start running the security verification test, installing the security kit, importing the module, running the scan. So it will do the same tasks. We're doing them on the machine. And now it's running the scan. This is for the first resource, and this is for the second resource, and this is the third and last resource. Now we have 28 resources, and because the build failed, The build failed because the security scan failed. So this will fail the build. Azure Policy. So Azure Policy, again, just the same concept is using for denying the policy or for auditing if the policy still exists or not. And we're using that for enforce and audit. The same concept of the continuous assurance, preventing and drift status. So for example, here, how we can use create and assign Azure Policy. Some example of Azure Policy that you prevent creating a specific types of virtual machine in a specific region. Let's talk about how we can integrate Azure Policy and release management pipeline. To review the deployment and the environment, usually we have different environment and we would like to promote our application from one environment to another. And this is the typical scenarios. But moving the application or promoting the application from one environment to another, it requires sign-in and sign-off. So for example, if I want to move or promoting my application from test to QA environment, I need to sign in. And this is usually by the approvers, which is in our case, the QA team. So either could be automated or manual, but it requires specific criteria in order to sign in. So what is the meaning of sign in? So the first is that you accept this release to be deployed in this environment. Because, for example, maybe this environment is busy or occupied by other work. So the first is by accepting that you agree to deploy these bits to this environment. The next is that you accept this release has all the definition of done for this release. So you approve that you received that. So you just sign in. You also accept to start working on this release. So once all of that, it means that you sign in to accept this release and to deploy that. Once this will deploy the bits here or deploying the application in this environment. And of course, we start working on that. Again, this could be manual work, this could be automated, but this means that there is working going to be happen once the sign-in process completed. After that, once you complete the work, then you need to sign off in order to move to the next environment. And the sign off here means that you approve that this release has complete all the work in this stage, and you approve that you done your work. You also approve maybe at the part of this that the next stage is secure. And this is our scenario in this case, that we will put part of the sign off that we will check for security for the next environment. So once this approved, then the sign-off will be completed, and this means that the deployment will be promoted to the next environment. So this is how we can integrate the sign-in and sign-off as a part of the process. The time between the sign-in and the sign-off, which is the time for executing the work, this is what we called build verification time. And this is very important KPI for measuring the DevOps, by the way. But at the end, we can use an Azure policy. For example, as you can see here, this is the sign-off. I can use the Azure policy to have this policy based on the target environment. And if this policy doesn't meet, the release will fail. So for example, as we can see, because this policy failed, then it failed the release. And of course, this is using the extension of Azure DevOps Kit. Automate governance and compliance. As we can see, with the combination of Azure Policy, Azure Automation, Azure Blueprints, Pipeline, and DevOps Kit, we can have different combination in order to automate the compliance and the governance and have what we call continuous assurance. For infrastructure validation, it means that we have different resources on the actual environment. And for example, if we have, let's say, for example, we have a whitelisted endpoints port, then we're using Azure Scan to scan these whitelisted endpoints to make sure that we don't have any port open that not whitelisted in our whitelist. And of course, any non-whitelisted port will be considered as a bug or a problem. Once we found vulnerabilities, we will create bugs in order to track them so we don't forget them as a part of the process. When we look at Azure Pipeline Security Extension, we have many extensions for many vendors that supporting different security practices, either for open source library, for source code, for license allowance, and many others. So for example, we can see here Sonar Cloud, White Source, Black Duck, Veracode, and many others. For example, if we look at Sonar Cloud, we can see here this can run the code analysis as a part of the Sonar Cloud. And here we can see the Sonar Cloud result, and we can see the vulnerabilities. Here with White Source Bolt as an extension for Azure Pipeline Extension. Here how we can install the extension. White Source Bolt is a free version from White Source Security Scan. Here's the White Source Bolt result. We'll explain this in details in the demo. And now let's see the fourth and the last demo, which is check vulnerabilities and the license compliance as a part of the CI/CD pipelines. Let's open the project, try White Source. This is the project that I will use to scan for security. Navigate to the repo. So as we can see, I use a WebGot project. So for those that they don't know WebGot, let me show you the README. So as we can see, WebGot is insecure web application which maintained by OWASP. So I will open the project homepage and the source code on GitHub. So this is the project web homepage, so we can see more information about the project. And here's the project on GitHub. So it is insecure web application that designed to teach web application security lesson. This is why it has many vulnerabilities to teach people. And of course here how to install the project and use it. So this is the POM or project object model. Because this is Java application, so it has POM, which is the file that include all the build instructions. And in the source, we can see that it is a web application. And here's the controllers. And also has test for unit testing. So it's a complete application. So let's navigate to the pipeline where I create a build definition. The first task of the build is npm to install npm on the machine, the build agent. The second is to use the Maven, which will use the POM file to build the application. And the third task is the White Source Bolt, which will be used to scan the open source libraries for either vulnerabilities or license. Of course, I need to install White Source Bolt extension on my organization, Azure DevOps organization. So here I should navigate to choose the repo, and here just to copy and publish the artifacts. So let's queue the build, and I will use Microsoft hosted agent and using the Ubuntu image. So this will kick the build, prepare for the agent. And once we get the agent start initializing the build, check out the file, npm install. Now the Maven building the application. And now the White Source Bolt. We can see there is many ignored files because the White Source Bolt is the free version and I can't change the configuration. So it doesn't include all the scanning for everything. So now it's complete the scan and copy the file, publish the artifacts. So if I navigate to the artifacts, I can see the package in the drop folder. I don't need it. And I can open the scanning report either from White Source Bolt, this tab, or from the navigation tab here. So let's open from here. So this is the scanning report, or I can open from anywhere else. Let's just get out of this page and I can navigate from this tab as well. So let's talk about the report or the scanning report. So the scanning report is divided into 5 sections. The first part is, as we can see here, the security analysis. The security analysis can give an overview of the scan, and this could be green, which means secure, or yellow, which means low, or orange, medium, and red for high. And this based on the highest severity found during the scan. The severity is based or according to the NVD or National Vulnerabilities Database. The next section is Vulnerabilities Libraries. And this is the total libraries divided into the secure libraries and the vulnerable libraries. And as we can see, we have 21 vulnerable libraries, and note that we have 20 libraries outdated out of 21 vulnerable libraries. The next part is severity distribution, which is a breakdown for the vulnerable libraries. So we can see that the 21 libraries here divided into 15 with high, 5 medium, and 1 low. The last part in this section, which is the aging vulnerable libraries, which include the time or the length of time elapsed during found the vulnerable for these libraries for the first time. The next section is securing vulnerabilities, and as we can see here, this is the table that lists all the vulnerabilities. The first column is the severity score based on the NVD, and we can see that we have also a link to the vulnerabilities on the common vulnerabilities database. We also have the description for the vulnerabilities. It also has the link for the NVD or National Vulnerabilities Database. So for example, if I click on the link on National Vulnerabilities Database, we can see that to get more information about the vulnerabilities, and of course also the top fix for these vulnerabilities. So this is the list of all vulnerabilities sorted by the high severity vulnerabilities first, the medium, low. The third section is license risk and compliance. This is the table of license distribution. We can see that we have 23 types of license in our project. And this table includes all the types of license and associated with risk level for this type of license and the occurrence of this license. The next part of this section is the license risk distribution, which display how many licenses occur for these types of the risk. So for example, we have 131 low risk and we have 4 high risk license. Of course, I can navigate more to get down. The fourth section is the outdated libraries. So we can see this is all the outdated. So I have 110 outdated libraries. So this is the list of table. And the first column is the name of the library. The next column is the version description, and also including the recommendation, which include the fix. For example, here, consider updating to the latest version. And of course, the link to the version. Also, I can see here the number of version released after my current version. So for example, here we have 44 new version after the versions that I use in my current project. So this is the outdated libraries, all the list. And the last part or the last section is the inventory, which include all the libraries and the associated license with a link to more details about each type of license. For example, if I open the MIT license, I can get more information about this license type. I can open another type, Apache 2, for example, and so on. So it lists all the libraries. This event was sponsored by Microsoft and DevOps partner GitHub. And this is part of the communities. In the end, thank you so much for attending my session, and looking forward to see you in other events. Please don't hesitate to reach out to my blog, mohammedradwan.com. Thank you.